Okay, so multiplicity, it is when a solution appears more than once. So this problem in here, the example, is example 1. We already did it, and here it is in the factored form. But I want you to think, even if this was kind of stretched out, 3x to the third is like 3 times x times x times x. And then we had the x plus 3, and the x plus 3. So if you were to like list each 0 separately, you could say, oh, well, this x equals 0, this x equals 0, this x equals 0, this x equals -3, and this x equals -3. So here's all the zeros listed separately. Now multiplicity, you would just say, now 0 is in there 3 times. So 0 has a multiplicity of 3, which means on the graph, this point right here, anytime it has an odd multiplicity, it's going to bend as it crosses the x-axis. And if it's an even one, then it just touches the x-axis. So -3, you'll see, is in there 2 times. It has a multiplicity of 2. And at -3, you'll see, oh, it just barely touches the graph, and then it comes back around. So you can't always tell the multiplicity of something by looking at the graph. You have to look at it in factored form to determine that. Now you can determine if it's an even or odd multiplicity, but that's about it from the graph. So look at example 3 here. X cubed minus x squared minus 25x plus 25 equals 0. So if we factor this, let's check if we can factor by grouping. Greatest common factor on the left side is x squared. We're left with x minus 1. Over here, my greatest common factor is -25. We are left with x minus 1. So then in one of our sets of parentheses, we have x squared minus 25. In our other set of parentheses, we have the x minus 1. And then still, we can factor x squared minus 25 as the difference of squares. So we write x plus 5 times x minus 5. And then you got the x minus 1. Which then your zeros, you have x equals -5. And then this one, x equals +5. And this one over here, x equals 1. Now, each one is in there only one time. So it has a multiplicity of 1. I mean, it doesn't even have multiplicity, really. So we'd say a multiplicity of 1 for all 3 of those. Now, usually when you're going to be dealing with these kind of problems, you're going to have a repeating thing there. So let's try the next one, and I bet that'll happen. Oh, yeah! So we have a greatest common factor. I see a negative for our first coefficient, so we're going to have to factor out that negative. They're also all divisible by 2. So if we kick out the -2, we'd have x cubed plus 6x squared minus 9x minus 54 equals 0. So if we were to then look for, the grouping, these have x squared in them, which would leave you with x plus 6. If we kick out a -9, we're left with x plus 6. So then let's write what we have here. We got this -2 out here. We've got the x squared minus 9. And we've got the x plus 6. Which x squared minus 9, again, difference of squares. So that would factor to x plus 3 times x minus 3. We also have the x plus 6. Now, these are going to give us 3 different zeros here. We have x equals -3, multiplicity of 1, alt of 1. We have this x equals +3, also multiplicity of 1. And that last one, x equals -6, multiplicity of 1.